In this video, we're going to look at how to find higher derivatives of implicit curves. So hopefully you already know, given a function like this, or not a function, given a curve like this, how to find dy by dx in terms of x and y, and then how to evaluate that at a point. Let's do that as a reminder, and then we'll look at how to find the second derivative. So finding the first derivative, we're just going to differentiate, so that becomes 2x, and we have to differentiate this implicitly. So product rule, here's our u, here's our v, so it's u, and then v dash, well v dash is dy by dx, plus u dash v, u dash is minus 1, and v is just y. Then differentiating y squared implicitly, we get 2y dy by dx. And that equals 0 because the derivative of 1 is 0. Now, we could find an expression for dy by dx in terms of x and y. I'm actually not going to do that, but I will just find dy by dx at the point 1. So subbing in x equals 1, y equals 1, I get 2 minus 1 times dy by dx minus 1 plus 2 times 1 times dy by dx equals 0. And that implies that's 2 dy by dx minus, so we've got dy by dx on one side, and then we've got 2 minus 1, so 1, get that to the other side, and it's minus 1. Okay, so there's dy by dx at that point. Now, the tricky one, the second derivative. So what is the second derivative? The second derivative, d2y by dx squared, is the derivative with respect to x of dy by dx. Okay, so let's just differentiate through here, through this line, and let's see what we get. So differentiating this one, we get 2. Now we've got the product rule here, so u, v. So it's u, v dash. So the derivative of dy by dx is d2y by dx squared. And then u dash v, so u dash is minus 1, v is dy by dx. Now the derivative of y is just dy by dx. Then product rule again, here's my u, here's my v dash. So it's u, which is 2y, v dash, which is d2y by dx squared, then plus u dash v. So the derivative of 2y is 2 dy by dx. But I've got dy by dx and another dy by dx, so that's dy by dx squared, which is, just to really nip this in the bud, is absolutely not the same as the second derivative. Okay, we now have everything we need. If we wanted the second derivative in terms of x and y, we could do that by isolating the d2y by dx squared and then finding an expression for dy by dx from this in terms of x and y, subbing in here. We just want to evaluate it at this point though, so let's sub everything in. So 2 minus 1 times the second derivative minus the first, well, it's actually minus 2 lots the first derivative, which was minus 1, so that's plus 2 for these two. Then it's plus 2 times 1 times the second derivative. Then it's plus 2 times dy by dx squared, so that squared is 1, so that's plus 2, equals 0. So in total this gives me 1 d2y by dx squared here, and then 2 plus 2 plus 2 is 6, so all of that equals minus 6. And so there's the value of the second derivative at 1, 1. And just for fun, it's nice to explore this in GeoGebra. So here's the curve, and here was the point in question, 1, 1. And you can see that it makes sense that dy by dx was minus 1. We do have a gradient that seems to be about minus 1. And what about that second derivative of minus 6? Well, that's because the gradient is negative here, and as x increases, the gradient is getting much more negative. It's heading to that critical point here. So that's why we have this negative second derivative. It tells us that the gradient is getting even more negative as x increases at that point. Okay, let's try this one now. A little bit harder, but same idea, and if you feel confident, pause the video and try this for yourself. Okay, our curve is ln x plus y equals 2y, and we want to find the value of dy by dx at d2y by dx squared. Okay, well, the derivative of ln of anything is the derivative of that anything divided by that thing. So we're going to be dividing by x plus y, and up here is the derivative of x plus y, which is 1 plus dy by dx. Now that's equal to the derivative of 2y, which is 2 dy by dx. So subbing in x equals 1, y equals 0, I'm going to get 1 plus dy by dx over 1 plus 0, so that's just 1, equals 2 dy by dx. So that's just 1 plus dy by dx equals 2 dy by dx, which means that dy by dx equals 1. So nice value for dy by dx at that point. Let's now go for the second derivative. Okay, we've got two options here. We either use quotient rule for this and then differentiate that, or we multiply through by x plus y. Now, I feel my intuition, if I wasn't paying attention, would be multiply through by x plus y, because I don't want to do quotient rule, because quotient rule, you get this squared denominator and everything just explodes. However, I don't need to find an expression for the second derivative, and I can just sub in these easy x and y values at the end, so I don't really mind about getting like the divided by v squared bit. That's going to be easy at the end. So I'm just going to do quotient rule. Here's my u, here's my v. So it's v times u dash. Now the derivative of this is 0 plus the second derivative. So that's just d2y by dx squared minus u v dash. So here's u, 1 plus dy by dx. And v dash is 1 plus dy by dx. And all of that gets divided by v squared, x plus y squared. Now, differentiating this side, that's just 2 times the second derivative. So I can now sub in x equals 1, y equals 0, dy by dx equals 1. So what is that? That's 1 plus 0, so it's just the second derivative here, d2y by dx squared, minus. Now, what is 1 plus dy by dx? That's 2. So that is 2 times 2, that's 4, so over 4. X plus y is 1, so that's just 1, and that equals 2 times the second derivative. So subtracting d2y by dx squared from both sides, I've got minus 4 equals the second derivative. So there we have the value of the second derivative there. And we're done. Okay, now for a much harder one. This is going to be a real monster of a question. So if you're not in the mood for just pages and pages of algebra, you can kind of skip through this or just work through it a bit faster. But let's get going. This is going to be tough, but we can do it. So let's go for it. Differentiating the left-hand side, we get, there's uv, so it's u v dash plus u dash v equals, okay, a bit of chain rule here. So differentiating sign of some stuff is the derivative of that stuff, which is 1 plus dy by dx, multiplied by cos of that stuff. Okay, so we're going to work with this to find the second derivative, but to find the first derivative, we'll need to rearrange this. So I'll need to get all my dy by dx's on one side. So that's x dy by dx equals, now expanding this over here, that's going to be cos 1 times cos x plus y plus dy by dx cos x plus y, and then the y from the other side. All my dy by dx is over here and factorized out. I've got the x from here, and I've got the minus cos x plus y from the other side. And that's equal to cos x plus y minus y, leading to dy by dx equals cos of x plus y minus y over x minus cos x plus y. So that's actually quite a kind of cute result there. Lots of nice symmetries there. Okay, now on to the second derivative. Now, we could start here, and if we did that, we would have to just do quotient rule, and it would be sort of enormous, absolutely vast quotient rule, and it would have dy by dx anyway, so it would have to be subbing this into this enormous quotient rule. So I think it's easiest to actually start back here. This is a good line to start at because it's sort of semi-expanded. We can just apply a bit of product rule there. So let's go for it and see what happens. So x dy by dx, product rule there. So u v dash plus u dash v. Differentiating this gets me minus 1 plus dy by dx sine x plus y. Now we've got a product rule here. So u and v, so it's u v dash. Well, okay, dy by dx, and then v dash is minus 1 plus dy by dx sine x plus y. So there's u v dash plus u dash v, so that's plus d2y by dx squared cos x plus y. Finally, minus dy by dx. Okay, now we need to get an expression for d2y by dx squared out of this in terms of x and y. Okay, now we can actually tidy this up a little bit. Notice that these two brackets here both have sine x plus y, sine x plus y. They both have 1 plus dy by dx, 1 plus dy by dx. So if we were to factorize out 1 plus dy by dx sine x plus y, 1 plus dy by dx sine x plus y, what's left is a minus 1 and a minus dy by dx. So overall, that's just a minus 1 plus dy by dx. Lots of 1 plus dy by dx sine x plus y. So that is minus 1 plus dy by dx squared sine x plus y. So that's cleaned up a little bit there. What else can we do? We can subtract dy by dx from both sides. We've still got this term here, the d2y by dx squared cos x plus y, and we've got minus dy by 2 dy by dx when I subtract that, and that's x d2y by dx squared. Okay, giving ourselves a little more room, we're almost in a position to get something pretty useful here. Let's get the d2y by dx squares over onto this side and factorize. So d2y by dx squared, and I've got x of them here, and then minus cos x plus y of them here. And over on this side, well, not much I can do with that just for now, although I do see it's two negatives here. That's fine. Maybe this is a good time actually to sub in our value for dy by dx. So it is minus, and then it's 1 plus, well, it's all of this, right? Cos x plus y minus y over x minus cos x plus y. And all of that squared, sine x plus y. And then we also have minus 2 dy by dx as well. So minus 2 times all of this stuff. So that would be 2 lots of, this is the first derivative, cos x plus y minus y over x minus cos x plus y. Okay, time to do a bit of cleaning up now. So my final step will be dividing by this, but just to clean it up a little bit, let's try to get this in a fractional form. So I can see that the x minus cos x plus y, that's going to be, or could be, a common denominator. So we're going to have to get that as a fraction over here. So what do we have inside here? Well, to get that as a common factor, it's going to be x minus cos x plus y plus cos x plus y. That's good, that's going to cancel. Minus y, and all over x minus cos x plus y. So that's good. That's going to simplify there. And here it's minus 2, all of that squared, and times sine x plus y. And then over here, I think we would like a common denominator of x minus cos x plus y squared. So I can just multiply the top by x minus cos x plus y. There's a 2 there as well. And then it's a cos x plus y minus y. And all of that is now over the denominator, which we ultimately want, which is the x minus cos x plus y all squared. So we're basically there, d2y by dx squared. So over here, all I actually have, because these two cancel, is minus x minus y squared sine x plus y. And over here, I'm not sure that does simplify that nicely. It's just minus 2 lots of x minus cos x plus y and cos x plus y minus y. And all of that can sit over x minus cos x plus y all cubed. I said it was going to be a monster, and it is, but just to go to show you that it can be done. All right, we're done with that, and I'll see you in the next video.